This is the second experiment about aqauation, cobaltpentaamminecholro complex. You have prepared in experiment 1 and you saved it in your locker. The principle of the experiment that H2O in an acid solution will replace the Cl minus, and we'll have a pentaamine aqua complex, and the Cl minus will go out of the complex. Now, the mechanism of the substitution reaction, it has either associative or dissociative mechanism, or IA or ID mechanism, interchange, depending on the complex and the environment. Now, if we check the possibilities, the rate of reaction of the complex, which is colored, is followed by the absorbance at lambda max, equals K1 times the concentration of the complex. And if H2O is involved in the reaction, the rate will be K second order times the concentration of the complex times H2O. Now, H2O being a solvent and high concentration, it will be included in K observed, and the rate will be K times K observed, which is K times the concentration of the H2O times the concentration of the complex. So the rate will be dependent on the concentration of the complex. Now, there is an example of the substitution reaction similar to our reaction, but instead of the Cl minus, we have F minus. This is a known mechanism, substitution in acid solution, and H plus attaches itself to the F minus, and HF leaves the complex, and H2O comes in as a substituent instead of the F minus. The mechanism depends on a rapid equilibrium, which is H plus attaches itself to the F and forms a complex with HF. Then the HF will dissociate and leave the complex with H2O. The rate equals K, the slow step, times the equilibrium constant of the first step, times the concentration of the complex times H plus. This reaction depends on the concentration of the H plus, and K observed equals K of the second step times the equilibrium constant. Our reaction will be performed in two acid solutions to check the concentration of the complex and dependent on acid solution. First, you have to prepare, when you come in the lab, 0.1 molar acid and 0.3 molar acid as HNO3. Now, you have to have two volumetric flasks. One is 100 ml volumetric flask, and the other is filled with 0.1 molar HNO3, and the other 100 ml flask filled with 0.3 molar HNO3. Now, you at home, before you come in the lab, you calculate the concentration of the complex, how much weight you need to form 1.2 times 10 to the minus 2 molar solution in 100 ml of this complex. Then you put the 200 ml volumetric flasks before you dissolve the complex in a thermostat at 60 degrees centigrade. When they equilibrate after 10 minutes, you add the solid to the 0.1 molar acid and 0.3 molar acid. You start the stop watch, and after 15 minutes you take two samples, one from the 0.1 molar and one from the 0.3 molar, and you run the UV visible. Then after each 10 or 15 minutes, you take another sample from each solution and you run the UV visible. You have to have 5 to 6 points, 10 minutes intervals or 15 minutes interval. You record the UV visible spectrum from 400 to 650. Now the H2O complex absorbs at 550 and the concentration starts increasing because it's the product. A infinity, you can calculate it. You don't have to wait for A infinity. You can calculate it assuming all the concentration you prepared. 1.2 times 10 to the minus 2 molar times the extinction coefficient at 550 will give you the absorbance at A infinity. Now you plot ln A minus A infinity versus time for the two solutions, and from the slope you can calculate the equilibrium constant K at 0.1 molar solution and 0.3 molar solution. If they are in the same range, the same value, similar value, that means it does not depend on the acid. If K2 in 0.3 molar acid solution is 10 or 15 orders of magnitude more than K in 0.1 molar solution, that means it's dependent on the acid concentration. Now your report should include the absorbance measurements every 15 minutes for the 0.1 molar solution and the 0.3 molar solution. Secondly, you have to have the plot of ln A minus A infinity versus time for 0.1 molar and 0.3 molar, and you calculate K at each concentration, and the justification why did we plot ln A minus A infinity versus time. Before you come in the lab, you should answer the questions. The first question, to account for why trans NH3,4Cl2 is 1,000 times faster than the cis in the substitution reaction. The second question is, why if we add Ag plus to our reaction mixer accelerates the reaction, makes the rate faster. The third question, you have the complex C2O4-3. It's like the ethylene diamine. This is it forms two enantiomers. Why does this complex racemizes faster than it exchanges the oxalate in solution? This was determined by using carbon 14. How do we use the isotope carbon 14 on the C2O4 in this mechanism? Suggest for question 4 the method other than the absorbance, UV visible absorbance, to follow the change in concentrations of cobalt in H35Cl. And the fifth question, why was 550 nanometer chosen as the wavelength? And question 6, you have the reaction of the cobalt chloro complex, pentaamine chloro complex with ammonia to form the hexaamine complex. Why the rate law for this reaction equals the concentration of NH35Cl x times NH3 to the y. Find x and y by changing the concentrations, the order of reaction. And the last question, why was HNO3 not HCl used? Why did we use HNO3 and did not use HCl? And this will conclude the second experiment in 434.